take this. Yes, it works. Good. Thank you very much to start with to everyone who's been here until this time. I'm actually quite amazed by your resistance. Let's try to make this interesting. My presentation is actually quite different from the others because it tells about a very technical work, which I hope is going to be interesting to most of you because it's a nice example of digitalization applied to this old technology and how the new and the hard industry actually come together. The explanation of this approach is actually because Optit, my company, is not an energy engineering company like most of us, really, but we are a spin-off company from the University of Bologna that makes its mission out of describing mathematical models and machine learning actual physical and business processes. So what you're going to see here is an application of mathematics and very complicated heuristic models to the specific problem that we are now facing. We've been lucky enough to be working with many companies and utilities in Italy throughout the whole value chain of district heating. We are optimizing generation, distribution, and increasingly working in demand. And this has brought us to support specific questions like, I want to understand how to develop my network. What is the best option for me? And best option to most companies is what is the kind of investment I need to make out of the multiple possible ways of developing a system of this dimension and size that makes the highest net present value. So we are speaking of an investment decision. And the challenge is that these are complex systems where there is a vast geographic dimension because there are quotas, there are length, there are different kind of pipings, lots of thermal hydraulic laws that need to be respected by the system. And the decision, in fact, is a mixture of physical and economic elements that have to come together. And of course, decision required the capability to play with lots of scenarios. So in the end, we developed something which tries to bring everything together. And this is the tool that we used to support the very highly challenging question that Beogradske Elektrane posed to us. Actually, by the way, this network that you see here is the Ferrara network in Italy, which is an interesting case of waste to energy plus geothermal being used to fuel most of a fairly large system in Italy. And the real reason we were called in this project is actually because we worked in Milan, and that's possibly why Dejan had mistook us for that, because the interconnection between Sila and Famagosta was one of the most interesting applications that we actually did, which shows that from digital to Earth is actually possible because the results that we produced there were actually implemented with very successful terms. But let's come to the challenge that we were asked to support the District Energy and City Initiative together with the friends from Enova, the university, and most importantly, the local utility. There is a vast system. I mean, Belgrade's district heating network is one of the largest in the world, I would say, without any, fear of being contradicted. There are lots of, Dejan said that there are 14 separated networks, and the possibility to use and leverage on some specific new green sources, or at least waste heat from the 10A and waste to energy facility. But the point is, in order to make the most of this, we need to interconnect these networks. How best to do it? This is the question. And there are many things that we need to take into account because we need to choose between one versus multiple connections. Can we renovate? Must we renovate the existing pipes? Do we need to build new pipes? How do the peak loads, the load influences our choices? Because in fact, the real question from Beogradske Elektrane was, will be able to run the network once we interconnect it with these new sources? I mean, will it be feasible? So this is a nice example of feasibility, a deep dive analysis on the feasibility of a very challenging development project. Of course, when a digital tool is applied to real life, a first long list of actions, and my colleagues who supported us in the project know this very well, is about making sure that the tool actually reflects the reality. So we spent a lot of time collecting data, and I must say that the level of I mean, the digital level in Belgrade is far from low. It is actually quite high, actually rather high. I can just say that, in fact, we benchmarked our system not only against field data, but also against Termis, which is one of the leading commercial tools in the market. So we came to a point where the system could be calibrated, and then we started playing with scenarios. And what I'm going to tell you about is what came out of this analysis. Out of the 14 networks, in fact, the really important ones for this project are 5. Zemum and Novi Belgrade, which are going to be treated I mean, as a subset, and sorry, Zemum and Novi Belgrade, and Dunavak, Kojarnik, and Novi Belgrade on the right. And the idea is not only to interconnect the thermal plant and the waste-to-energy facility, but also to connect the new customers to the network, together with the reconstruction of a number of pipings. Take into account that we have to deal with 2 networks. I mean, the 2 systems are actually going to be managed operationally in different ways, temperature-based regulation versus flow-based regulation, which is something that needs to be taken into account if you want something to work in reality afterwards. So we are really dealing with a very high degree of complexity. But the good thing is that, I mean, working hard together, we came up with very, very interesting conclusion. What's going to happen in the new Zemum-Novi Belgrade system? Of course, we were looking at the hydraulic balances, understanding what we could do with the possibility to reopening a number of previously closed pipes, and what we should be done in terms of opening some new backbone constructions together with pumping stations. For you who do not know, possibly are not familiar with the system, this is the position where the new source connection actually comes. So with respect to the overall network, it is quite, I mean, on a side of the system. So if there is a vast availability of heat in this point, how can we make sure that it covers the current Novi Belgrade system and the Zemum system? Of course, we need to interconnect it. The interconnection will allow to close the existing boiler house in Zemum. We want to connect new user up here, but in order to do it, we need not only to connect the new source, but also create some pumping stations. And the system was actually used to make sure that the old chain could actually be working in practice. These are just some of the examples of what actually was produced, and it's very interesting to see. I mean, this is the thermal hydraulic study of the system. So when you see dark blue, it means that there is a lot of pressure, which means some resiliency and security that you can actually potentially link more customers. Bear in mind that even when the green color is there is still enough pressure to serve those customers. So everything is feasible because one of the requests to the system was I mean, to actually serve all customers and find the right balance to make sure that it would actually work. The interesting point of the study is actually that with the new system of pumping, where we decided there is going to one area of the city which is this one. Oh, sorry, it is actually not too okay. This part here. will actually become even more resilient, and the rest of the network will continue to be served in an appropriate way. Bear in mind that this new system is going to be one where all heat comes from the tent A, and we are going to be closing the existing boiler. So yes, it works. From current to perspective, it works. And what is more interesting is that after a lot of calibration, after lots of runs, we actually came to identify exactly the balancing point whereby the hydraulic pressure figures at the plant are actually more or less the same. You can see that the power supply is basically 10 before and after, and the return is there. So basically, we have not changed anything at the plant side, which is very, very important, and was one of the requirements from Beogradske Elektrane. The local boiler house will be closed. And interestingly enough, the level of investment necessary for doing this, taking out the investment for the big pipe from tent A, is actually almost nothing. I mean, 2 months. We are speaking of non-investment. It's yes, if we manage to get the heat at the source, the rest is doable, and it's actually very, very little costly. So, very good news from Zemun Novi Brega. Let's look at the other system, which is a bit more complicated, because here we are speaking of maximizing the supply of the new sources, taking into account that lots of capacity will have already been used by the previous system. Here there are significant altitude differences that pose technical challenges to pressure management, and there are some existing and pre-existing elements that should be eventually refurbished. So the color that you see in the system actually show that this is the project that we were asked to validate at the beginning of the project, where the green lines are potential new backbones. There are some existing backbone power lines that could be refurbished, and in this area here, there were some boiler stations that could be shut down. Lots of new users to be developed in the area that you see there. And and of course, again here, the idea of having some new pumping stations. So let's see what the challenge here was really quite complicated, because we wanted to minimize operating pressure, find a trade-off between cost and technical benefits, understand exactly where the heat would actually travel from the new sources towards the new areas. But maybe let's see what actually came out. This is the result that came out from the project. And basically, all the hypotheses have been confirmed to be possible. I mean, we can close the existing boiler houses. We've understood exactly what are the piping diameters that allow the system to run. Most importantly, we've managed to understand that there is a long section, the outer ring, the so-called outer ring, that has proved not to provide significant benefit, which means that we can save a lot of money in terms of what is necessary to actually build there. Of course, this doesn't rule out the fact that due to other conditions and other scenarios, one may want to go back to those plants, but what is necessary to have a working system which will be able to accommodate and have manageable and good use of tent A and the waste-to-energy facility heat is actually feasible. Let's go in some details here. Again, exactly as before, the availability, I mean, if we look at the current status, which is there, the availability of a lot of waste heat coming from this side, obviously changes the condition of pressures throughout the whole network. And we actually studied two different scenarios. One whereby Novi Beograd, Dunav, and Kojarnik are connected together, but we know that we can also split and use valves in order to only use the Novi Beograd and Dunav as a system. This allows for different scenarios that could be put in operation at the same time, alternatively, but without significant investment. We can, there are going to be operating ways to push the excess heat more towards Dunav, covering more this side of the network, or allow the heat to cover this part of the network and be pushed more towards Kojarnik, depending on the needs that the system actually wants to have. This again means that yes, we can use the excess heat properly with relatively small investments on the network, and very importantly, we've also seen what happens after 50% load, which tells us about what's going on, not in very high season, but in those middle seasons where actually the potential of using waste heat is actually even larger. And we can see that the effect on the hydraulic system is actually improving and increasing the pressure while decreasing the need to use the existing Kojarnik and Dunav system. So in the end, the system has not only been tested from the hydraulic standpoint for the peak, but also to make sure that off-peak situation could be served at the best possible way. So we are reaching peripheral section of the network without any critical points, and we can really make use of the new existing availability of heat in the best possible way. Some final conclusions. It's very good that we've tested the future flexibility of the system to work in different manners depending on the way the utility will want to operate the system itself. We've ruled out the need for long segments of pipes, the outer ring, to be necessary for the system to be in place. And this is very important. Yet we've understood what are the best ways to refurbish some segments of the existing line to comply with technical constraints. And this is really a very delicate and fine thing, which was really the big question from Beogradske Elektrane. Again, it's interesting to see that this part here, with respect to 100% flow, there are smaller pressure needed at low load conditions, which means that the need for the former plants to actually pump in heat is decreased, which again is another demonstration of the confirmation that the project is actually good. And again, the full investment decision will actually be paid back in less than 3 years. Bear in mind that we are not considering the cost of the big pipe from TEN-T. So in the end, it's, condensing 1 year of very tough work on analytics in a few slides is always very complex, but it's been a very interesting and fruitful experience, and I think that we've managed to provide Beogradske Elektrane with the confidence that yes, it can be done. Yes, we now know what needs to be done in order to get there. And it can be, and it will be operated, which is really what a pre-feasibility should be doing. Also, the fact that the digital tool has been able to both be relevant for a system such a complex system and generate hundreds more than 100 scenarios is actually quite a remarkable achievement. Let me just say that this tool, together with other best practices, is part of the booklet that Paul Voss mentioned before. So I'm glad to say that in a way, what we've applied here is what is now being presented and studied in European projects like Upgrade DH as one of the means to achieve and improve existing district heating networks in Europe, which I really think that is what everyone in this room is trying to achieve. So I would thank you very much, and I'm here for questions.